Good evening. Welcome to AAC and our lecture as part of our workshop Medical Campus. We're looking at densification and how to create quality spaces within the demands of densification. Tonight's lecturer, Joep Kuijs, has come to us from Stuttgart, and he's partner at hammeskrause, and they specialize in complex building tasks within a number of industries, including education, health, and research, which is very much part of what we are looking at. And in Hamburg, they only recently completed the Max Planck Institute. He will talk about, and a number of AAC alumni also studied at Delft, where you studied, and there's another connection through your work at JSW. The architects, as their founders, were also studied at Aachen with Volkwin Mark, and were also Assistenten of Volkwin Mark in Aachen. So it's all quite tightly together around the subject of education. I'm very much looking forward to your talk. Thank you very much for being here.
Thank you for the introduction, and thank you also for the invitation. I'm very honored to be here. I'm one of 3 partners at hammeskrause Architekten. I will show you a little bit about our office before I tell you about 4 laboratory buildings that we've done in Germany. Our office is specialized in laboratory buildings, so they are all very complex buildings for research, for science. We've also done some cultural buildings, some school buildings, but most of our tasks are laboratories and buildings for science in general. So laboratories is still a very wide field. And I will show you 1 biochemical laboratory today and 4 physical labs, and I will show you the difference. But first, hammeskrause Architekten was founded and named after Markus Hammes and Niels Krause. Just if you're wondering where they are, they sold the company last year to Tobias Döring, Dana Bilek, and me, and we all came from within the company. I was there as well for about 7 years, left for 5 years, and now I'm back since January. So that's, in case you were wondering why we're called hammeskrause, it's named after Markus Hammes and Niels Krause. We are a very diverse team, a very young team as well. It's really fun to work with these people on complex tasks like laboratories. So to start off with, I want to tell you why is it fun to design a lab and what is exciting about it. First of all, a lab needs precision and lives off precision. So you can build any space where you build your experiment. Has to be like, there's a lot of very complex requirements, and it has to be very precise, precisely made for these requirements, for the experiments and the science to work. At the same time, a lab lives of flexibility, because you don't know what the science is going to be in 5 years or what science is going to need a few years from now. So at the one hand, you have these specific requirements, and on the other hand, you need the flexibility for the building to last more than a couple of years, and to make the building sustainable as well. This precision means you need a lot of building services, HVAC systems, lots of gases, lots of other media, and this is what most of the building consists of, but most lab buildings. It's the case, of course, for any building, but lab buildings, it's even more technical stuff. On the other hand, the fun part is the part where scientists communicate, where they meet each other, and that's what we always try to enhance in our buildings, that we create this space for communication and for meeting points. So in a way, we create high-performance buildings that are inconspicuous, and this is a balancing act that makes working on lab buildings and designing lab buildings fun. A little detour to the past. to show you what a lab building consists of. If you look at this image, you see that in the 16th century, alchemists had like fire, they had ovens, they had vessels with liquids. So basically, alchemists were creating space to build their experiments. This didn't change for a long time, and we needed more space for liquids, for some experiments, more space to build labs, to build experiments, workbenches, spaces where scientists can be free to build what they need for their science. And to be honest, this still hasn't changed a lot. We still just are creating workbenches for scientists to build their experiments. Of course, the technical stuff has changed. The microscopes are better. What has also changed are the safety requirements. If you look at what is needed for a lab, the safety requirements to protect the scientists is a lot higher than for alchemists hundreds of years ago, of course. And you can see here, the lab codes are here. There is a very high, or a very big, long list of rules to enter this lab. You cannot bring your coffee to your workbench in the laboratory. And what has also changed is the standing of science in society. So alchemists were still hunted by the church, so to say. But after the war, I guess you all know this building by Louis Kahn, the Salk Institute. This is one of the most monumental buildings ever built for science, I think, but it's also a great laboratory. Because what Louis Kahn did was build one floor completely empty, and then the floor above completely full of all the technical things he needed for that science floor to work. So it still works as a great laboratory today. And you can see by this building how the standing of science has changed in society, and luckily so, it's not hidden away, but more and more part of our cities and campuses. So I want to go through all the little elements that a laboratory building consists of. I know you also have to design one or two in your workshop in Cologne. So I'm just going to go through all the elements. First of all, you need lab benches. These are like strictly ruled by German workforce regulations, so they are usually 6 meters long. There's a 135-meter grid that they are on. So like this is very like the very basis of a lab building. Then next, there's the evaluation stations. They are usually right next to the workbenches, and they used to be inside of the laboratory. And what's been new the last sort of 15 years, I would guess, is that they've been taken out of the lab area so that you can now also take your coffee to your evaluation station. And what happens here is that scientists put their data into their laptops. So they do their analysis, they do their research at the workbench, and then they sit at these evaluation stations and enter their data, and they need like a working spot with their computer close to the lab. Then there's the equipment rooms. These are rooms that are full of autoclaves. There are cooling cells. There are all kinds of very highly technical things that scientists may need to perform their experiments. And they usually don't need much daylight, so they need to be close to the labs, but close to the workbenches, but they don't need daylight. Then there's office space. When a scientist has worked on an experiment for a few months, he then usually goes to the office and works there for a few months. This is quite standard, I would say. And what's different from office buildings is that in a laboratory building, you need lots and lots of ventilation. Because of the safety requirements in the laboratories and because of the high standards to hygiene there, we blow 4 to 8 times as much air through laboratories as we blow through offices. Like that's the standard. So you can see here on the right that the shafts for ventilation of the offices are very small, but compared to the shafts that we have on the left, for the lab area. And this means that you really need to think about the structure of the building right from the beginning, because you need to go through those shafts. And if you forget about the shafts in the beginning of the design process, it's very hard to just cut away a corner, of course, to add such a large surface area. And then there's the meeting points. And we, in our office, we really believe that the meeting points are the center and the main part of the buildings. We think that you can create all those perfect conditions at the workbenches, but if a scientist doesn't accidentally meet another scientist during his coffee break and talks about his ideas, then maybe he will never get a Nobel Prize. So like this is really needed for the exchange of ideas. Also, of course, for regulated meetings, but also for those spontaneous meetings that we always try to stage where those happen. So meeting points to us are the center of lab buildings. And all the other things are important as well and have to be perfect and work perfectly, but the meeting points, we think, is what makes the lab buildings work or not work. So if you look at this building that I just showed you the floor plans of, it's called CETEP, it's a building in Kiel. We are still building it. You can see that we have all these things on the right, the offices, the equipment rooms, the lab benches, more offices here. And then we sort of carved out the meeting area, and this is what it looks like, or looked like a few months ago on the building site. You can really see how it's already starting to work. There is a big staircase for people to meet on. There are office or meeting rooms floating in the air. So we have one side that will become very technical to the right, where you can see those technical working areas of the laboratory, and one side that is a lot freer. And we really feel like in this project we carved out this meeting area from the substance of the technical building. And hopefully it will look like this soon, but I don't have newer pictures than the ones from the building site yet. Because there's scaffolding now, so you cannot really feel the space anymore, of course. But here you can see very clearly this juxtaposition of the technical part and the free part of the building. That was just a little sidetrack. I will show you 4 projects, as I said. The first one is in Cologne, right next to the Frauenklinik, or in the same area as the Frauenklinik, and where you're doing your workshop. And this was what the site looked like back in 2008. So you see the Frauenklinik is here, and this is the University Hospital, and all these plots, and also this GMP building was still missing. This building is not there, and this was a very heterogeneous, empty plot of land that we did a competition for the MPH. It's the Max Planck Institute for the Biology of Aging. So scientists study how cells, how the aging process works in cells. So it's a biochemical laboratory, and it's about aging. This is how we usually start to work. We try to order the program in all kinds of different geometries. We try different kinds of meeting zones, different atriums. And this is here you can also see part of the fun of designing a laboratory. There's still lots of possibilities. You can do a comb structure or atrium structures. Anything is really possible. It really depends on the program and what kind of lab you are designing. But in this case, because the surroundings were so empty, we decided we wanted to fill the plot as much as possible. So this heterogeneous space towards all the sides, we didn't want to add more useless space to it. That's why we wanted to build this square building and fill the plot to all sides as good as we could. Here you see the student way or the student path that you are also dealing with in your workshop, and this was the only lively part of the plot. So we decided in the ground floor to put the cafeteria here towards the student path, and also the lecture hall towards that side to the south, and landscape that area. Sorry, I went a bit too fast. This is the main entrance towards the street, and then you have these public areas right next to the main entrance toward this public path. This is what it looks like if it's nice and full. I think maybe last week when you were there, it did not look like this. But but at least in summer, when everyone's having their lunch, it's a lively area. To then fill this building plot with the program, we really studied the program and looked at how this particular institute was organized. Of course, the scientific areas were central, and we decided to put a lot of the infrastructure and supporting functions of the labs on the ground floor and at the top floors, and have the two floors with the scientists in the middle. And we found out that the program of the building could sort of be divided into 3 departments. We put some things together and separated some things, but in the end we found there were 3 main clusters of laboratory program, and that gave us the chance to put this, as simple as it sounds, this triangle into the square, and leave this communication zone in the middle. We wanted to connect all the departments, so all the departments between each other had to be connected, and then the middle area is the zone that was sort of supposed to attract the main communication. This is a sketch by Marcus Hammes, the center of gravity is what we called it back then. So the central area was supposed to really be the life of the building. And this is what the typical lab floor plan looked like. I'm going to go through it quickly. Each department has the lab benches here with the evaluation stations right next to it. Then towards the middle of the building, there's the equipment zones. You can see the very large shafts that each area has their own circulation of air. So there's 2 shafts in every department. The offices are located toward the outside of the building. And what was really special about this design back then, so the competition was in 2008, but it was one of the first buildings, at least in Germany, to really open up these zones, these evaluation stations towards the outside. So for the first time you could go there without having your lab coat on. You could take your coffee to your working desk, and that proved to be very popular in this building, and is now a more common feature of laboratories, that you can enter those spaces from the side. Here in the middle, you see that this is where you go to get your coffee, next to the meeting rooms, so you really have to go to the center of the building. We only had 2 floors of lab benches, a little bit more, but mainly 2 floors. And the building was a lot bigger. You can see that the ventilation center, basically, and you can see all the technical areas in the basement and also on this floor. But we didn't want to make the atrium that big. So that's why we decided to lower the roof. When you enter here, it's a little bit suppressed. So you enter this suppressed zone and then enter the atrium, which has, I think, still a decent size. This is what it looks like today. I've heard you weren't allowed to enter, or at least you couldn't enter last week. Unfortunately, it's not open to the public, but it's a very differentiated space. You can really see that these three departments are very present, each of them. This is what it looks like from the other side. So you can see also the technical areas above the roof, that the building is a lot taller than it looks in the atrium. And this is what those evaluation stations looked like when they were empty. And here you can see how they really worked very well for this project. So instead of being a place where you go with your laptop, put in some data, they almost became like office spaces. I don't know if it's according to work regulations, but the ASR probably wasn't thought for this space. And here I picked this photo as well, so you can see that the inner lives of the lab benches and those working areas, that it really comes to life. On those first pictures, the atrium looks a little bit clinical, I think, but it's not. That's not how the atrium works. You can really feel all the work that the people are doing there, and you can just literally see them, of course. And we have these orange floors that help a little bit. So it's a very lively building. I will say one little thing about the facade, because this was the building, the Max Planck Institute for the Biology of Aging. We chose tombak, which is a material that ages. So this is what the facade used to look like, and then slowly it became darker. And today it's probably darker than this, but it's a representation of what the scientists are doing inside. The next project, or the next 3 projects, are here in Hamburg. And all of them are physical laboratories. So that was the only biochemical one, the one with the classical lab benches. The physical laboratories are a little bit different. We are here in Bahrenfeld. It's a little bit to the north from here. So we are somewhere here right now, and Bahrenfeld is to the northwest. And what's special about this campus, the campus is on the bottom right of this slide, is that there are several particle accelerators that are built underground. One of them starts in the state of Schleswig-Holstein and shoots particles towards Hamburg. Then there's a few more, and they are all hidden. You don't really see them. You see them a little bit in the architecture and the shapes of the buildings on the campus. I'll show you that later. But our building site was more or less here. It's a little bit hard to be that precise with the pointer. And what was special about this project is that for maybe not the first time, but it was not very common back then, that 3 institutes wanted to found a research institute together. So the Max Planck Institute, the university, and DAISY, which is part of Helmholtz, they decided to build a building and make a brief together for one research institute, which is the CFEL. This was our site. Bahrenfeld, this campus in Bahrenfeld is a campus that is very, very heterogeneous. So you can see that the Petra Hall, this hall has the shape following the particle accelerator. Then here's the Louvre Chaussee on the right. That's a busy street that's outside of the campus. And all the other buildings have been added over time, and when they needed a building here, they put one there, and it's not really coherent. There have been some ideas for master plans for parts of it, but still this site back then was very amorphous. You had the trees to the back, then this Petra Hall to the front. There's a little water basin right here. There are some other lower buildings right next to it, so it's not really, you don't really know where the center of the campus is when you're on this site. You really have to guess. The program was about half office, half research, and a little bit of meeting area, as it usually is. And that's also quite typical for our buildings. We, of course, started trying. But what's special about these laser laboratories is that the requirements to the vibrations that are allowed inside this room are very high. So if you measure something with a laser, you can really not use any vibrations, and it has to be really very still. So all the laser labs had to be on the ground floor, spread out over the site, because only on the ground floor you can make sure that the vibrations are low enough. And then the offices, we wanted to put the offices on top, and we decided to put them as much together as possible so that we could stage this communication again, that the people wouldn't have to walk across the entire site to go from one office to the other. And this was our basic layout. You see the access to the experimental areas on the ground floor was in the middle, so it's easy to reach. There's an experimental hall on the right, towards the south. Then we made sure there was access to the theoretical areas or to the offices. We make this space more dynamic because we thought to cater for this kind of communication, we really wanted to make this space in itself dynamic and not just a boring rectangular atrium. Can also be good, of course, but in this case we really thought it was good if those 3 institutes would sort of be morphed together in this space. And then the building volume itself was also made into a cylinder. First of all, because there was not much context. Like as I showed you before, the site was very very heterogeneous. And this being an institute for 3 different research institutes, we had the chance to sort of create a little icon in the corner of the campus for this new institute, for the CFIL. It also gave us the chance to create 3 lenses, as we called them. And each lens was supposed to be for one of the research institutes. So one for the university, one for Max Planck, and one for the DESY. These voids were the communication spaces, and we created bridges between the lenses as well for people to meet. And then, of course, each lens had an access point. And then we had to adapt the shape, mainly of the ground floor to the side a little bit, which gave us the opportunity to have this setback here and create sort of a natural entrance area to the building, right in the middle. And here you can see that this way, even sort of a little bit of a square starts to come into existence in this place. Even though we're still on the edge of the campus and the cylinder is now visible through the trees a little bit. You can see it a little bit through the trees in winter at least. And also on the campus, the cylinder is quite visible if you are in this corner of the campus. And here's a model of the 3 lenses. So each lens was supposed to be one of the institutes, and all the services, all the staircases, the toilets are the tubes that are sort of stuck through the lenses. But in the end, the institutes decided to each occupy 1 floor. So that idea didn't survive, but it still works because there were some staircases as well, so they can still go visit each other and look at each other's research. There are offices all the way around, but also towards the atrium in the middle. And then the communication zones were really supposed to be here on the bridges and in between the office areas. This is what the building looks like. If you're ever in the area, it's possible to, this one is possible to at least walk into the atrium. And we have some meeting rooms and lecture halls in the ground floor, a little cafeteria in the back. This space, you can really see how the scientists are able to see each other and see how they work from a little bit of a distance. And those bridges are the connecting parts. The ground floor with the laser labs, each laser lab has sort of a table as a working bench. And each laser lab needed a door towards the outside because in case one of the experiments gets picked up and needs to be transported to one of the particle accelerators, it wasn't possible to go through the narrow hallway, so each of the laser labs needed their own doorways. And here's a big experiment hall on the right, and then there's 2 courtyards, so that also here, even though it's quite a long and stretched building, you still always see light, and it's not really a long, dark hallway when you walk from your office to the experimental area. Those areas, the areas here, are the technical areas, because here, there, as well as in the chemical laboratories, here there's also lots of installations. The ventilation requirements are very high as well, but we couldn't put the ventilation center on top or at the bottom and go through the entire building. So we had to think of this zone of where to put the ventilation right from the beginning. And here you see one of the laser labs. Basically, it's just space for scientists to build their experiments. Like, that's the same thing in all the laboratories. You just need to create a space, a playground, exactly. The requirements to the vibrations were so high that we, like, very early in the preliminary design, had to think about, okay, how is the foundation? Do we need to build it this way or that way? And it was all, of course, researched what would be the best for the building on this location. You can see that there is a lot of very thick concrete slab here, and here you see the laser labs with the technical areas right below. And this section to the right was created very early in the design process, which is very difficult to get the engineers to really think and draw these kinds of drawings in a preliminary design stage. It's almost impossible. But for a building like this, you really have to do it, otherwise there is no space and it will be a mess later on. So luckily it worked here. You can see here how the ventilation comes up from this tunnel, and is then at the top is then led towards the labs, and here's the door towards the outside. This is what the building looks like from the back. So the Louvre Chaussee is on the right-hand side behind the trees. You see all the doors, and on the other side, because of this, of the way we put the labs in the ground floor, we were able to create a little bit of an entrance square and an address towards the campus. So that was the second project. Now I have a little detour again, because I've been talking about the inner workings of a lab mainly, and how the meeting points are central for us. But the other topic I wanted to talk about is how to connect this to the city, or in most cases to the campus. Because a laboratory building, as I said before, becomes more and more important, or science becomes more important in society, at least I hope it still does. And there are some tools that by a few of our projects that I won't show in much detail today, some tools that we have used. And the first one is, of course, super simple, but science is less scary if you can see what people are doing than if you cannot see what people are doing inside of a building. So we like to present working areas to the outside, or at least towards the atrium, towards each other, but if possible also to the outside. This is the BMF in Lübeck. This one is also on the campus in Hamburg, creating a sequence of public spaces from more public to semi-public to private also helps. If you have an atrium that people cannot enter, like the one in Cologne, that's always a little bit sad. But here you can at least walk onto this square, you can walk into the atrium in the building. And then if you have these spaces for spontaneous encounters, and those spaces are part also of the public tissue of the surroundings of the campus, of the city, we think that also really helps to sort of open the building and what the people are doing inside the building, open it up to the city. Then it's always good to accommodate public walkways and adapt to whatever is happening around the building. And in the best case, you have a little bit of program in your building that is public or semi-public. So if you can put a lecture hall or a cafeteria or something else that is public somewhere in the building, then of course you can guide visitors and have them enter your building. So those are a few of the things we always, tools we like to use. The question is though, how much of them can you use? And it always depends on each specific project. So I will show you the two other projects I will show you today. Both have a very special connection to their surroundings for different reasons. One is the Max Planck Institute for the one right next to the CFEL for the structure and dynamics of matter. And you can see that the site was also heterogeneous here. And this is the water basin that was still there, and there was a forest right here. This is the main, or not the main, but one of the entrances to the Bahrenfeld campus from the Louvre Chaussee. And it would have been logical maybe to create an address here, right by the entrance of the campus. But we thought in this case, we wanted to create an entrance to the other side, to the CFEL building. So when we tried our studies, most of them left the forest in the back towards the entrance of the campus, left it free. Again, these were laser laboratories, so we had to put the laser labs on the ground floor for vibration reasons. And in the end, we decided to put these workshops and laser labs on the ground floor, then have a second floor till here and a third floor to here. So the mass of the building really focuses towards the CFEL to create this public space on that side, and at least have a little sub-square within the campus that has some meaning for the people who work there, hopefully. This is what the model looks like. What we did to, and what I meant by connecting it to its surroundings is we sort of tried to extend this forest area, this green area, onto the building. So there's 2 terraces that are very green, and the mass of the building, as I said, is more towards the front, which creates this movement in this direction with the mass of the building. To emphasize that, we decided to materialize the base in the design of the facades and have an immaterial joint in the middle and then have a materialized top, so that this top would look heavy towards the square and would be a really, that the building would be very present there. And then there's the movement in the other direction of the people entering the building. So you have the square towards the seafall here. This is where the main entrance is. And then there's a series of atriums. And if you enter the building, you sort of follow the light and you end up on the 2nd floor where you end up in the cafeteria, that in this case is not on the ground floor, but right here, right next to the top garden, which is one of the most beautiful spaces of, like, with the nicest views and the nicest area of the building. So you can see that this diagram sort of became the building. We materialized the base and the top and had this joint in between. We were asked in the brief, because this was the Max Planck Institute, the Max Planck was also in the Seefeld, so we were asked to connect this building in a way with the Seefeld, which is why we went for the same color in this case. We were also specifically asked to make the building as nice as the Seefeld, but not nicer. So we had to create a working area that was at least as good, but they didn't want all their scientists to want to move from one building to the next. This is what the building looks like from the Seefeld. It's 150 meters long, as I said, so it's very, it's a very long, we emphasize this length with this base. And here again, you can see the doors towards all the lab areas, because each lab needed their own door. It's always very difficult to get them to disappear, but in this case, it worked quite well. And if you enter the building, like I said, there's a series of halls and atriums, and you are sort of guided by the light towards the cafeteria at the top floor. The gardens are quite spectacular, to be honest. They were designed by L+, who also did the Hochbunker here in Hamburg. And what is special about these gardens is that they are public, or at least as public as you can get on a campus area. But there's a staircase here and a staircase here, and everyone who is on the campus can just enter the roof area, walk through the gardens, smoke a cigarette, talk to the scientists who work there, who maybe also take a break there. So at this building, those meeting areas and those spaces for spontaneous encounters are more on the outside than on the inside. They also exist on the inside, but it's not as logical or not as logical to go into the building. It's very easy to take this staircase and cross the roof of the building, because if you don't do it, you have to walk 150 meters that way and 150 meters back. So here you see how the building is connected to the Seefeld and how it really stretches towards that direction, and how it's on the other hand connected to the little forest in the back. So we are very happy with how that turned out and how the roof gardens look today. They are still very, very nice. And here you see the start of this public walkway, which is also a little bit carved out of this long mass. Then the next project is also in Hamburg, right next to the last one. So you see the Seefeld at the top, the Max Planck Institute here, the entrance towards the campus was here. And we were asked by the client to design a building with laboratories for school children, which was, we thought, a great chance, because the client already invited school children from the city of Hamburg to the campus and wanted to have them try science and talk to scientists, do workshops. It was a very small building. They wanted to put the building right at the entrance, and this area looked back then a little bit sad. It's not just because of the weather. But it's a bit like a gray area anyway. There's like these kind of buildings were there, and there were these 2 trees that were there that the client also told us we could just cut down. The program was very small, around 600 square meters. So to make this work, the first thing, we tried lots of different options again, but what made the most sense was here at the top right, was a layout that had everything on one floor, so that everything was close together. The workshop areas, the lecture room, there were not that many rooms, so this was the one that to us back then made the most sense. Also here, I forgot to mention, but here's a little, like a small garden, sort of a little bit of a nice area. And if you put it this way and stay in line with the building next to it, it was clear, okay, we would have to cut down the trees because you wouldn't be able to save them. So then we went back to, okay, maybe we need to do 2 floors after all and stay back from the trees. But this just didn't really work for the program because there would be one practice area, there would be one lab area, but you need to go back and forth all the time. So we decided that wasn't really an option, even though it works for the 2 trees. And then in the end, we decided that the one room that was more public, so this lecture room, we could put it into the garden and extend beyond this line of the neighboring building. So this is what the little model looked like. We thought also the entrance would be here, or would be to the right. But yeah, there's a little bit of a basement for the service areas. We wanted to keep it as low and as little intruding as we possibly could. And then we, during the process, thought, okay, but if these trees are here and we're staying away from them to save them, then we can also showcase them. And at some point, we decided to extend the roof of the building around the branches of the tree. And here you can see how that worked in a model. And then we decided if we do that, we can make that area around the tree the entrance area to the building. And that was a great opportunity. This is what it looks like today. I think the tree looks better than before the building was there. And the entrance area also gave us the opportunity to build a little ramp and lift the building up from its surroundings so that it's sort of floating a little bit. It's really intruding as little as possible onto its surroundings. In the back you see the little forest that was behind the Max Planck Institute. Of course, a building like this comes with a lot of issues. And but once the idea was there to save the trees, everyone on the project really cooperated, and everyone was very helpful. Even also the construction companies, they came up with ideas and like really solved a lot of problems on site, because the trees, of course, we had made a measurement and knew exactly where each branch was, and then when we started building, that had changed, because apparently because of wind, tree branches move, so these kind of situations had to be solved on site, but everyone was willing to cooperate. What was also needed is that the foundation of this area around the tree consists of very thin poles as not to disturb the roots of the building, so as little as possible at least. Yeah, it changed the design in many ways. But today really is one of these spaces between the public area. You can see the street, the Louvre Chaussee in the back, and then you enter the campus, and then you enter this little square, and then you enter the building. So to have this sequence going from public to private, we think worked really well in this case. The floor plan is quite simple. So there is workshop rooms, practice rooms. They wanted 2 entrances, one from the front, one from the back. And that's basically what it is. The lecture hall is here in the garden, or the lecture hall is more a workshop room. Also laser laboratories where school kids can practice with lasers. And what's a nice detail, I think, is that we managed to hide some of the surfaces and some of the technical things in the ceiling. So you can see that this line from the outside of the roof continues into the building, keeping it very, very thin and very sleek. And here is how it works today. So it really extends this into this little garden in front. and yeah, it's a great, very picturesque building because of this tree growing out of it. So those were just two examples. And the question is, or the question I also want to ask you for tomorrow is, like, how can you connect a laboratory building to the city? And so I showed you some tools that we used, but it's, of course, it always depends on the kind of laboratory. It always depends on what is on the program. The program also might change. Maybe in the future we need to build lots of server racks for AI, who knows? But in the basis, you just need to create a space for scientists to work and to build their experiments, a space that you can do anything in. And that space can also be in existing buildings. This was a shirt factory turned into a lab, so it's not impossible to build a lab into existing buildings. You just need to really think of how to get all the technical requirements right. And like I said, in the end, it's just about meeting those technical requirements and creating the playground for the scientists. So this balancing act between communication zones and technical spaces with high hygiene standards, with lots of ventilation, that's really the fun part of designing a laboratory. And I think in the future, we can even more integrate labs into the city and create spaces like this that are green. This is a competition that we lost, but maybe it will look like this anyway one day. And I think that is a very nice challenge. Thank you.
Thank you very much for your insightful lecture and all the beautiful images that I think are very encouraging to understand that in buildings, you said earlier, with high technical demands, the qualities can sometimes get lost in the priorities, but I think these images showed an approach that can counterbalance that very well. Are there any questions?
The title Labs in the City.
Yeah.
The title was about labs in the city. The laser labs in Hamburg, is there a technical requirement to have these doors closed, or was a design decision with this base to have everything which looks beautiful, but doesn't give much to the public street?
That's true. Those doors needed to be closed because that's where the experiments happen. That's where they cannot have the vibration. So those rooms for the experiments are usually always closed off in case of physical laboratories or laser laboratories. So yeah, in that case, and they have to be on the ground floor. But so you really have to pick the moments to open up the building, like and where to build the address of and where to enter the atrium. It's a little bit different with the biochemical laboratories because they need daylight because people work there. It's a working space, so those are a bit easier to open up. Yeah.
You showed us these layouts, and I was wondering if you could say something about circulation. It seemed that at certain areas there are certain types of circulation that are critical for how a lab works. We also looked at the Frauenklinik, which has the patient circulation and the doctor circulation, which is now not part of our brief anymore, but it looked like maybe there are certain categories of circulation in labs as well.
Well, there's always the problem that some of the lab areas need to be closed off for security reasons to external visitors. But first of all, you have circulations for the scientists. The scientists go to the lab as if they go to the office, then they go have lunch, then they go back to their lab, or they go to their office space. Then there is a little bit more public circulation of the people coming from the outside to visit a lecture or to talk to those scientists. But there's never or there is rarely like a clear division as there is between patients and doctors, because it's a little bit more amorphous, or like not as clear to just separate them. I think it really depends also on the building. Sometimes laboratories want people to come and visit, like at the Lights in Schools. That was, of course, a great opportunity for us. But mostly there are different levels of security, and you just need to separate them, and there's no way around it.
How deal scientists with public interest? I mean, I could assume, I think that they are more the type of people that like to be by themselves and do their stuff, maybe exchange things with their colleagues, but are not that keen on publicity. Is that right?
Yeah, that's very often the case, and a lot of scientists still like to sit in their room and not be bothered by anyone. Yeah, like it's a bit of a cliche, but it is often true in those physical or like highly scientific areas. Yeah, we hope that a building like that also challenged them, of course, a little bit to get out of their caves and show their work to others. But yeah, it's a thing we have to deal with. I cannot.
Well, thanks for the lecture. In the first slide, you talked about precision and flexibility.
Mm-hmm.
And one of my questions is, do you think about deconstruction and reconstruction of the whole building?
More now than 10 years ago when these buildings were opened. So this competition was actually one where we separated the offices and the laboratory completely, so that the laboratory area, the lab area, could have like the services on top and below and have a basement, and the office area could be completely made out of wood. But still, we designed the lab area as well as a prefab building that could be deconstructed. So yeah, it's a topic now, and we see it in briefs also more and more, of course. But when those buildings were opened 10 years ago, that was not really an issue yet. No.
Yeah, thank you for the presentation. And my question is, how do you integrate sustainability into building a lab?
Well, it's the same as for most other buildings. So in Germany, there's a regulatory system. The Max Planck, the third building I showed, had a DGMB certification of silver. So from the beginning, you have someone who advises you and says if you use this much recycling concrete and so on. So that's the technical part on the one hand. On the other hand, there's the flexibility side of it. A lab building is more sustainable if you can still use it in 30 years. And for a lab to be able to be used in 30 years, it needs to be, like, you need to be able to change the ventilation system easily because of new standards. You need to be able to reach all the areas that the ventilation system or other technical systems have been built into. So we think about it in that way, that we try to make it easy to deconstruct little parts of the systems in the building and create these rooms that you can build your experiments in any way. Because as I showed in the beginning, what scientists do hasn't really changed. It's more the standards around it that change over time.
Yeah, thank you very much. I have kind of an odd question. You showed all the different parts of a laboratory and all those different parts that have to interact. And my question would be what parts of the building could be split up? What could be put in a different building? Because all the buildings you showed were one complex. How would it be possible to split it into different buildings?
Yes, partly. It also depends on the client always. Sometimes a client wants his office to be right next to his lab, right? And you really have to put it together. But sometimes, like in this competition, we decided to sort of have two building parts, and they could have been almost two buildings. As for the technical areas, the lab benches and the equipment rooms and the evaluation stations, those always need to be close together because that's how the lab works, and also to get the chefs to get the air there and so on. So what you could take out is, I guess, the offices if you wanted to.
Before we go through and have a glass of wine next door, I would like to thank the audience for finding their way here today, because we have lots of building sites and it's very difficult to get here, so thank you very much. And I'd like you to join me to thank Joep Kuijs for his excellent lecture. Thank you very much.
Thank you.